Welcome to Civil 21 DA. Course title, Geotechnical Engineering 1. Course code, CEN341. Course teacher, MD Abdulaziz, lecturer, Department of Civil Engineering, Port City International University. Presentation on soil classification.
Today we will discuss about soil classification. Soil classification. Firstly, we have to know what is soil classification terminology. In the soil classification, there are different categories. In the categories, properties include groups and subgroups. Based on application to their provided engineering behavior and application. Classification of engineering purpose should be mechanical properties, permeability, stiffness, and strength. The aim of classification may be established for conditions which will allow useful comparison to be made between different soils. Most of the soil classification purpose based on index purpose. Index purpose such particle size distribution and plasticity. Two soils may be quite different even though they are obtained for nearby boreholes on the sub construction site. Thank you everyone.
Good morning everyone, I am Sadia Singh. My ID is CEN670. Today I will continue the presentation. It is classification mode. There are three types of classification mode: textile system, USDA system, upstream system. Textile system. In this figure, we show the textile classification system where three sides of the triangular represent the percentage of sand, clay, silt. This triangular has 12 zones. Each zone represents each type of soil. The left side of the triangle represents percentage of clay, which is increased bottom to top, and the right side of the triangle says which is increased top to bottom, and the bottom sand which is increased right to left. For example, 10% sand, 16% silt, 13% clay. We know sand represent bottom and sand is clay. This sign represents all the point is soil, and silt is
Assalamualaikum everyone. My name is Muhammad Arif Hussain. My ID is 670. I will discuss about the Unified Soil Classification, which we know as USCS. According to USCS, the soil divided into two categories. One is coarse aggregate soil, and second is fine aggregate soil. Which are the coarse aggregate soil? That are in that C200, they are less than 50% retail. The particles are in percentage 50% less than the total. And the fine aggregate soils are in 200 seed is greater than or equal 50%. in unified soil classification, we can group the soil into design symbol, two capital letters, and first letter represents the main soil type, and second gradation and the plasticity. Let's see the symbols we used for coarse aggregate. G for gravel, P for full aggregate, W for well graded, and C for clay. In fine aggregate, N is silt, C is clay, O organic matter. In fast letter, remember that we will in first letter, and L is low plasticity, H is high plasticity, and that portions are secondary. Thank you everyone.
Namaskar everyone, this is Chakraborty. My ID is CA02106666. Today our discussion topic is about unified soil classification system, and I am going to present the coarse-grained soil. First of all, there are some symbols of coarse-grained soil. Basically, soil motion, we divide the soil into two parts. One is gravel parts and another is fine or sand parts. There are some group symbols here. If we divide that, the left side letter is the particle name and the right side letter is the, their gradations or plasticity. That means S is sand and W is swell grade. This is we also introduced by GW. Then SB, this is also introduced by GP. This is poorly grade sand or gravel. Then N. What is that? N is silt. That means the silt particles are gravel sand, and G is organic gravel, GC well graded silt clay, SM same portion. Then fine aggregate. Fine aggregate also is the left side portion is silt and the right side portion is low plastic, high plastic, chassis. Okay. Then we get to some mathematical term. First of all, here we see a mathematical term. First of all, we need to do sieve analysis. In sieve analysis, the portion 4.75 above is called gravel portion. Then the portion 4.75 to 0.075, the portion is called sand, and 0.075 millimeter portion down is called silt and clay. This is the main things. Main things is coarse-grained soil and fine-grained soil. Our gravel and sand particle mixed coarse-grained soil, and silt and clay particles are fine-grained soil. Here some terms R4, F4, R200, F200. What is this? R4 means the percentage of retain above 4.75 millimeters. That means their gravel. F4 means the percentage of fine aggregate passes through 2.75 millimeters. That means they are sand. R200 means the percentage of retain 0.075 millimeter. That is also sand. And the F200 is the percentage of pass through 0.075 millimeter. That is called silt and clay. Another thing here. How can we remember that this is coarse-grained soil and this is fine-grained soil? We see that the retain percentage 200 C for 200 C, it is greater than 50%. Then we tell that the portion is coarse-grained soil. And if the F200, that means the fine particle that pass through the 0.075 millimeter is greater than 50, that means it is fine-grained soil. Then the mathematical term. Here given these two, F200 means 11%. What is 11%? F200. We said that F200 is the retain percentage that above 0.075. That means this is just particle. Then R4. R4 means the rigid particle above 4.75 millimeter. We said that the rigid particle above 4.7 millimeter is gravel. That means our gravel portion is 80%. First of all, gravel we find silt and clay find. We know that gravel plus sand plus silt and clay equals to 100. So 100 minus 80 minus 40 equals to 68. This is our sand percentage. Now R200. The rigid percentage of 200 silt down over the 0.075 millimeter. That is 86%. How? We know that F200. F200 means the percentage pass through 0.075 millimeter. And all of them 100. So the else percentage is R200. That means 100 minus 14% equals to 86%. Then F4 means the fine particles passes through 4.75 millimeters. So the other things are gravel percent. 100 minus 80% equals to 82%. That's all.
Stress on soil. So, introduction. Berzani, 1925, developed the concept of effective stress, which became a key concept in modern soil engineering. And effective stress in soil contributes to its strength potential. Here we can see that the contribution of effective stress in soil engineering is mainly contributes in strength and volume change. Also, effective stress influences the capillary rise, seepage force due to water flow, quicksand, which is also known as soil boiling, and heaving at the bottom of excavation. Stress versus effective stress. Here in this diagram we can see statement of soil. In the first statement we can see that soil is an assemblage of particles of different shapes and sizes. Explanation of this statement is soil is actually a mixture of particles of different shapes and sizes. The second statement we can see that the soil skeleton is a major body to resist against external forces. When we apply external force in the skeleton of soil, in the body of soil, because of the particles of different shapes and sizes, it creates an interparticle force vector which resists against the external forces. It does determine when the soil is dry or saturated, interparticle forces are in equilibrium with the external forces. The interparticle forces are in the same level with the external forces. I'd like to invite Sham Professor Rana for
Today I'd like to discuss about what is electrical. How well if the soil is separated of partial saturated for water pressure interval, and also there is some part of external force. We can easily explain soil exam. Now we use the and this is a piston. Plus right this piston, and we have the space for water pressure. There are some water inside the body. Finally, we find that sigma equal to sigma prime plus P. That is the main concept of the total stress and effective stress. After the different effective stress, equal to sigma prime to sigma minus. That means sigma prime plus u equal to sigma, then sigma prime will be will discuss about effective phase contraction in soil mass. Each soil at a certain given subjective overburn phase, which generally determines the current formation of the soil. Soil which study water table. Here we can see the water table. Water table. This is height H1 and height H2. Number 1 and height H2 and height H2. These surfaces are water surface. Space of soil for height H1 and this portion is soil for height H2 and this portion is soil width for height H2 and you can see that total space. Total is sigma equal to H1 gamma 1 plus H2 gamma 2 plus H3 gamma 3. Here sigma is unit weight of unit weight. And here you can set submerged water. For submerged water, 2 water mu equal to H3 minus H2 into gamma W. Gamma W means unit weight of water. এটা না এটা যারা এটার পর এটা এটার পর একটা আজকালের পিডিএফ বাচ্চা নেই establish submerged soil. When soil under the water, then space is H1 into gamma W. Space is not affected by the depend on water. Effective distance cannot depend on height. Here you can see that problem. Now we will calculate this problem. This H1 is unit. H1 is 4 H2 9 H3 5 H4 calculate the total space. Given total space, sigma equal to H1 gamma 1 plus H2 gamma 2 plus H3 gamma 3 plus H4 gamma 2. They have like the value H1 4 into gamma 1. Gamma 8.2 plus H2 9 into unit of soil 90 millimeter plus H3 value is 5 into calculate the value here. Then support pressure. Support pressure sigma equal to the water surface is here. H2 is equal to H4 minus H2. Gamma H4 is 6 minus H7. We know that because of water, gamma is equal to sigma G. For water, density that into 9.81. This one and effective space. Doing the effective space sigma pi into total state this minus 4 water. Total space subtract to 4 water. And this get 2 meter depth from an ocean bottom surface under the 30 meter deep water. The soil unit weight is 17.30 Newton cubic meter. অর্থাৎ এখানে another map for this map H1 gamma S for H1 meter into gamma S. The soil of unit 17.5 unit of depth. Then ocean bolt of surface under 1300 meter. HW into gamma W. HW 1300 into gamma W 19.81 kilonewton per meter. That is calculated. Thank you.
Hello everyone, myself Sharutamjan. My ID is CN02106685. Now I am talking about the value of stress in material goes on increasing with interest in applied axial load, but it has a certain maximum limit. The minimum stress at which a material fails is called ultimate tensile stress. It means the maximum force. The maximum force before the failure occurs. The end of elastic limit, which is elastic limit as the limit per unit area within which material behaves elastically. This can be seen during experiment as explained later in procedure which increase in loading elastic limit initial cross section area goes on and finally reduces to its minimum value when the Thank you everyone.
Assalamualaikum everyone. I am Mohammad Tariqur Rahman from group number 5. IDCN 021067112. Today our presentation is about soil classification. At first we need to know some terminology. A soil classification system. In the first part, it is said that we divide the soil into defined groups and subgroups based on their application or to their overall engineering behavior. And then second part, the classification that we are doing for engineering purpose is basically classifying it by dividing on three characteristics. These are permeability, stiffness and strength. So by dividing these three properties, we divide the soils. We divide the soils for engineering purpose, that which are called mechanical properties. And in this part, our main purpose is one thing in the classification system is to establish one thing in the classification system, which give us some conditions. Give us some conditions that we divide the soil, divide soils. Here division means liquid index and plasticity limit. And the last part, the soil that was we divide in the classification system, basically depending on index properties. Here index properties means particle size distribution and plasticity. In these two things, we divide the soils. Anyway, index properties is very important term in respect of geotechnical engineering. Here, appraisals are not in this part. Appraisals are not the same. They are different by depending on their origins, composition, location, geological histories, and many other factors. Two soils may be quite different, even though they are obtained from nearby boreholes on the same construction site. In situ and laboratory tests on soil specimens are very important to obtain their index and engineering properties. In situ and laboratory tests, in these two tests are depending on the index and engineering properties. Convenient for engineers if soils are categorized into several groups with similar engineering behavior. Engineers are divide the soils into different categories depend on their engineering behavior. If anyone asks us what is soil classification, we say that the process of categorizing soils with similar engineering behavior is known as soil classification. That's it.
Now I am going to present classification mode. Soil classification mode basically three types. First one is textural system, second one is USCS system, third one is ASCO system. In our previous session, we already know that soil classification mode are three types. Now I am going to first type textural system in briefly. The US Bureau of Public Roads represent triangular system, which is called commonly called textural system. Textural system, we can see that three sides are represent percentage of clay, percentage of sand, and percentage of silt. The textural classification system has 10 zones. Each zone represent is soil. If we identify the zone, then we can easily identify the types of soil. First, we come to this zone. This zone is for clay, because the clay is located 30% for sand, 50% for clay, and 40% for silt. The major constituent of this zone is clay. That's why we classify this zone is clay. Then come to the next zone, sand. The sand is located 80 to 90% for sand, 0 to 20% for clay. So the major constituent of this zone is sand. So this we classify this is sand. Now come this zone here, 0 to 20% for silt, 80 to 100%, 0 to 20% for sand, and 80 to 100% for silt. So the silt is located, the major constituent is silt. That's why we classify these zone silt. Now one question come to our mind: why we consider this portion is silt? Why we do not consider this portion is silt? Because if we see that here the percentage of sand is greater than the percentage of silt, so that's why we cannot classify this zone for silt. When we working textural classification system, then one term is come. This is loam. What is loam? Loam is a mixed soil content of sand, silt, and clay. Then come to this point. This is the sandy clay is located for 60 to 40% for clay, and 80 to 100% for sand. Here clay and sand both are present maximum best. That's why we consider this portion is a sandy clay. This one is silty clay. Here 40 to 60% for silt, and 70 to 40% for clay. But if we check the sand portion, we can see that 0 to 30% for sand. So if we compare the percentage of sand and silt, the percentage of silt and clay, the percentage of sand is very low for silt clay. That's why we do not consider percent of sand for silty clay. Basically, textural classification system, we use the identify the different constituent consist of sand. If we come to the definition, we here say that basically textural classification system we use for mixed soil. What is mixed soil? Mixed soil, basically mixed soil are consist both sand, silt, and clay. Table 3.15. Here we know that on the basis of diameter, when we call gravel, sand, and silt and clay. If the diameter is greater than 2, then it is gravel. If the diameter is 2 to 0.05, then it is sand. If the diameter 0.05 to 0.002, we call silt. If the diameter is less than 0.002, we call silt. Loam is used to describe the various type of mixed soil. We already know this. Loam is used for the classify the mixed soil. The percentage of sand, silt, and clay present loam are 40%, 40%, and 20%. Thank you everyone. Now
thank you, Shatabdi Mitra. Assalamu alaikum, sir. Good afternoon, everyone. I am Wishi Borwa Diba. I am from Group 5. My ID is PEN717. As we know from Shatabdi Mitra about the textural classification system, here we encounter the word loam, which describes various types of mixed soil. But in soil engineering, the term soil is not used. That's why Mississippi River Commission system modified this textural classification chart without the word loam. Here it is seen. We can see in the graph that this whole part is named clay because there the percentage of clay is higher, 50 to 100%. Boundaries have been given for different types of particles like sandy clay, silty clay, and clay sand. Here the amount of clay is higher. That's why it was named after sandy clay and silty clay and clay sand. And this is how the particles have been classified equally and also renamed. This is how the textural classification system has renewed the triangular chart. Now I will discuss about the most important classification system, which is Unified Soil Classification System. According to this system, soil is classified into two categories. One is fine-grained coarse-grained soil, and the other one is fine-grained soil. The coarse-grained soil are basically gravelly and sandy, and here the 200 feet more than less than 50% are generally called coarse grained soil. For example, if we take a soil, another type is fine grained soil. Fine grained soil here as 200 greater than 50% means percent final corresponding to hash 200 feet is greater than 50%. So we can say that the soil, if the soil passed through the hash 200 feet more than 50%, then it will call fine grained soil. Thank you everyone. Now I call my next team member to continue this.
Thank you, Ishan. Hello everyone. Myself Surai, CN 01306082. It's my ID number. Now, the soil classification, the soil classified into 15 groups. Each group is divided in simple consists of 2 capital letters. The first is based on their soil types, what kind of soil it was or it is. The second letter is based on the gradation and plasticity. We can see there is coarse grain and fine grained soil. This is the alphabet. G is gravel, P is poorly graded, M is silty as sand, W is well graded, C clay, and M is silt, C is clay, or 0 is organic. The first letter and there is another is second letter. L is low plasticity and high plasticity. In previous slide we talk about this two. This first letter is this and second letter is this. Now I would like to invite our next speaker.
So my name is Hassan Islam. My ID is CM010671. Now I describe coarse grain. Here GW means well graded sand. GP means poorly graded sand. GM means silty gravel. GC means clay gravel. SM means silty sand, and SC means clay sand. Here our team member described G means graded, W means etc. Now fine grained soil. CL fine grained soil. CL means low plasticity of inorganic clay. ML means slight plasticity with inorganic silt. OL means low plasticity of organic soil. CH means high plasticity of inorganic clay. MH means high plasticity with inorganic soil. OH means high plasticity of organic soil. PT means peat. Here O means organic, and the others are inorganic. Thank you everyone.
Thank you, Hassan Islam. I am Dr. Hachachi. My ID is CN010670. Assalamualaikum. Now I am discuss the mechanism part of this topic. Here you can see SIP analysis goods, which is used for SIP analysis. Which those aggregates are not past the 75 mm SIPs, they are called boulder. And here you can start from 7.4 mm SIP, 7.4 mm SIP to 0.075 mm SIP. Here, which aggregate are past the 4.75 mm SIP, they are called sand, and which aggregate are not retained from 4.75 mm SIP, they are called gravel. And here you can see silt and clay. So which particles are past the 0.75 mm SIP, they are called silt and clay, and which particles are not retained 0.075 mm SIP, they are called sand. Here you can see some another mark. One is red and another one is blue. So what it means? So F4 is means the which aggregate are past SIP number 4. Means that means percent fine of the SIP number 4, and which particles are written from 4.75 mm or SIP number 4, they are marked by R4. And R200 means
the which percent final which is written from sheet number 200, and F200 means the percent final which is find of sheet number 200. Here we can see the another term, R200 is greater than 50. If that means if 50% of the total aggregates are written from sheet number 200, they are post-grain soil, and which aggregate are F200 is greater than 50. That means the 50% of the total soil which are passed from sheet number 200, they are called fine grain soil. I have already discussed about this thing in previous slide. This Here we can see the another term, the naming of the aggregate. There are F200 is 40% and R4 is 80%, and we can find the gravel, the value of the gravel, sand, silt, and clay, and R200 and F4. So firstly we should find the gravel. We already know that those particles are written from sheet number 4. They are called gravel. That means the R4 80% is gravel. The sand, there is sand. So how can we find the sand? So those particles are find from sheet number 4, and those particles are written from sheet number 200. They are sand. So if we plus this to F200 and F4 R4 and minus from the total aggregate, we can find the sand. Silt and clay. We already know that those particles which are passed from which are passed from the sheet number 200, they are silt and clay. So here R4 is 40% and F200 is 200%. That means these particles are passed from sheet number 200. So the silt and clay is F200. It's 40%. Now for R400, how can we find it? R400 means which particles are written from sheet number 200. So here we can see that the particle of final of sheet 200 are 40%. That means if we minus from the total aggregate F200 from total aggregate 40%, we can find R200. That means total aggregate is 100% and minus 40%. We can get this R200. And F4 means which aggregate are find from sheet number 4. That means here written 4 R4 is written by 4 nong sheet. That means if we minus for R4 from total aggregate, we can find the F4. Thank you everyone for your
Assalamualaikum everyone. I am Abhishek Choudhury. My ID is CN02106728. Now I am going to talk about unified soil classification system. We already know that soil is coarse soil, fine grain soil. Here you can see first one is coarse grain soil. If the value of R4 divided by R200 greater than 0.5, the soil is gravel. We can identify gravel as capital G. Now I am going to talk about some various types of gravel. First one is well graded gravel, second one is poorly graded gravel. The criteria for this is uniformity coefficient is greater than 4 and coefficient gradation value ranges from 1 to 3. Similarly, for poorly graded gravel, if the
gravel don't follow these two criteria, it will be poorly graded gravel. CC gravel and clay gravel. The criteria for CC gravel and clay gravel is plastic limit for CC gravel plastic limit is less than 4 and for clay gravel plastic limit is greater than 7. And for clay gravel F200, the percentage of F200 is more than 12%, similarly for CC gravel. These four types gravel are mixing gravel of well-graded, poorly graded, CG and clay gravel. Next one is fine grained soil. If the liquid limit is more than 50%, then it will be silts and clay. In the plasticity chart, there is a line called A line. We will find MH below the A line and we will find CH above the A line. And we will find OH in the OH area. And the last one is high organic matter.
Assalamualaikum everyone. I am MD Location Science. My ID is CN013673. Today I will discuss about unified soil classification system. Here we can see a chart, higher plasticity chart, and there at x-axis there is a liquid limit, and at y-axis there is plasticity limit. Here we can see two lines. One is U line and the another one is L line. U line is nothing but limitations for classifying fine grained soil. If we get the plasticity index number is beyond the U line, we can't say that it is fine grained soil. And there is a liquid limit. If we divide it by a perpendicular line, there is 0 to 50. The first half will be 0 to 50, and the second half is 50 to 100. And then when the plasticity index is above a line, we can say that it's a high plasticity clay. But when the plasticity index is below U line, we can say that organic silt. That means when it's beyond above the line, it's for clay part and this for silt part. I already described about this chart. If the result of our soil test beyond the U line and we need to repeat the test again. Now let's see a numerical problem on the CU and CC, which is U means the coefficient of uniformity and CC means coefficient of curvature. To determine CU and CC, we need to know about D10, D60, D30 and D60. D10 means 10% finer and 90% written on the strip. To determine the D10, we need to draw a line from percentage finer 10%. We need to draw a parallel line, then the perpendicular line from the strip size, and this is D10. Similarly, D30, D60. After determining the strip size, we need to put it at our formula. For CU, this is D60 by D10. It is the strip size, the ratio, which is 6.67, and the formula for CC is D30 square divided by D10 into D60, and the value comes out that 0.74. Now we need to talk about decisions. Is it clay or sand? Is it gravel or sand? Find CU. We know that find CU is greater than 4. It would be gravel. Find CU is greater than 6. It will be sand. Now we need to do decisions about the CU. Our result comes out 6.67. That means it's sand. It's sand. Then here the CC, which is 0.674. It's beyond the criteria. 1. So we cannot define as the CC. So our decision will be it's a uniformly sand. That's all for today. Now
Assalamu alaikum everyone. I am Mahmoud Islam Mughal, IDC 02106731. Now I would like to discuss about this example where laboratory has performed light brown sandy soil which usually has several pieces of gravel larger than 6 mm. You get that we have here a plastic limit and liquid limit. Now we have to classify this soil USCS. We have here some seed number 40, 200 and the passing percentage 98, 36.5 and 28.5. Where in seed number F200 the passing percentage is 28.5%, which is less than 50%. That's why we can say that this are coarse grain soil. Now our R4 we have the percent change 2%, and we have a equation that R4 divided by R200 which value actually 0.276, which are less than 0.5. That's why you can say that this is soil in this side. Another one is F200 here. 28% is greater than 12%. The group soil is SM or SD. That means silty sand or clay sand. Now we have to find out is it clay sand or silty sand. That's why we have to find plastic index, where we can find this plastic index, which are now we have to find out is it silty sand or clay sand. That's why we need to find a plasticity index, where we have a line. Here I have equation 3.73. Which result is 9.676, but we found here is 10.6%. But if we put the plastic limit, then we find in a line which is 9.676. That's why if it is which we find is 10.6%. That's why it is Atterberg limit on Atterberg on a line. That's why we can say that it is clay sand or clay sand with gravel. Here we have another classification of soil, another system of classification of soil, which is Haskell classification system. It's actually based on 3 categories: grain size, plasticity, and bubble or boulder are encountered. Here the grain size, we can say that if the number 10 knocks if retain that will be the gravel. If 200 were retained, that will be the sand. If the seed number passing through the 200, that will be the seed or clay. That's all for my.
Assalamu alaikum everyone. My name is Engineering-1. My ID is CM02106726. Now I discuss about the plasticity. We already have some ideas about plasticity. The term silt is applied when the fine friction of the soil have a plasticity index of 10 or less. Here it is said that the index of fine particles is 10 or less. If its value is 10 or less, we call it silt, and if its value is 11 or more than 11 or 11, then we call it clay. Now we will see about cobbles and boulders. Basically, they are extruded from the portion of the soils. And according to this system, the soils can be classified in 8 major groups, and 1 through 8. Which is based on their grain-size distribution, liquid limit, and plasticity index. Now we will see how this classification are happening. A1, A2, and A3 are coarse grained, and A4, A5, and A6 are fine grained. And the last one is A8 is peat, which are highly organic soils. So this is my presentation. Now I would like to reveal my next image.
Assalamualaikum everyone. I am Minhar Abdullah Galib. My ID is 734. Now go to the chart. Here we see stone fragments, gravel and sand. How we identify them? Here A1 category is divided by A1A and A1B criteria. If soils are passing number 10 SIP more than 50%, they are A1A, and if soils are passing number 10 SIP not more than 50%, they are A1B. Number 40 and number 20, number 200 are similar than number 10 SIP. They have no liquid limit. Their plasticity index PI is maximum 6%. Here fine sands are A3 category. They are passing number 40 SIP minimum 51%, and number 200 SIP maximum 10%. That's A2 slide. A2 category is divided by 4 criteria: A24, A25, A26, and A27. Here we see number 200 SIP. All of soils are passing maximum 35%, and their liquid limit A4 maximum 40%, A5 minimum 41%, A26 maximum 40%, and A27 minimum 41%. That's A24 and A26 and A25 and A27 are similar, are related, because here we see A24 liquid limit and A26 liquid limit are same, and plasticity index A24 have maximum 10% and A26 tend to crossing minimum 11%. That's number 200 SIPs. All of soils are passing minimum 36%, and their liquid limit and plasticity index are similar than previous slide. Their general subgrade rating fair to good. That's all.
Assalamualaikum. Today I am going to discuss about faster classification system. The classification system based on following two categories: grain size. Picture passing the 70 mm sheet and retaining in the 10 number sheet is called gravel. Picture passing the 10 number sheet and retaining on the 200 number sheet is called sand. Silt and clay. Picture passing the 200 number sheet is called silt and clay. And my next slide is according to the present from this system, soil can be classified according to the 8 major group A1 to A based on their grain size distribution. Based on their grain size distribution, liquid limit and plasticity. We can understand on this slide. Soil can be classified A1 to AN. And my next slide is my next slide is Pika. Soil are classified under A1 to AN is Pika. Group number A4, A5, and A6 and A7 called fine grain, and group number A1, A2, and A3 called coarse grain. And my last slide is Large soil is coarse grained and fine grained soil. If 35 less than 20, 200 numbers is called coarse grained soil, and 35 is more passing through the 20 numbers, 200 numbers is called fine grained soil. That's all.
Here we start a plasticity chart. S76, S75, same of the in this slide S6 and 26. When main part is up, then S6 and 26 and 24, 4. When down in 10 and step here. Asto basically is when we granite soil used for high subgranite material, and it's called group index DI. That's all.
Assalamualaikum everyone. This is Muhammad Tanimul Kaisar, ID 695. Asto classification group index is to describe components of soil when used for pavement construction. To build a pavement construction, we need to describe the soil performance. To know is to place a soil in a particular group. It means getting the bed of soil as a separate material within its own group. To higher the value of GI, group index, boron is the quality of material. The quality of performance of a soil as a subject material is inversely proportional to group index. The group index is given by the equation. We can classify the soil from this equation. Group index equal to finite 200 minus 35, 0.2 plus 0.005, liquid limit minus 40 plus 0.01, finite 200 minus 15, plastic limit minus 10. And there is a group belong to group at 2, at 6 and at 27, at 27. For this group we have to use group index. This equation, group index equal to 0.01 at 200 minus 15 plus 60 minus 10. That's why today I would like to invest the next lesson.
Assalamualaikum everyone. My name is Sunil. My ID is CN742. Here you see that here is the example which is solved by two methods. Which is one is ASCO and another one is USCS. I will solve it at ASCO. We know that for 200 seed soil seed passing is less than 30%. When less than 30%, it is a coarse grain. We see it here 30% seed passing, which is less than 35%. It is a coarse grain soil. According to the plasticity chart, it is A26 group. It is A26 group. For A26 group, group index is this is group index formula, and we can solve it. 90 is the plasticity index, which is plastic limit, which is 90. We calculate and we get minus 0.18. We don't take minus side. Then we will take 0, which is good soil. At group index, which is 0, that is a good soil. That's all.
My name is Now I talking about Unified Soil Classification System. The person is passing from 200 feet at 200. Strong plastic
7% less than 7. It is strong. And R4 is equal to the soil of gravel. Are we in 100 less than 2.5 soil of sand, soil sand. And after we give above a line, so the soil classification of USS. That's all.
Assalamualaikum, this is Salman Alislam. My ID is CN013741. Here we can see a card. We have to find out CC and CU. First of all, I have to know which kind of soil is this. So we have to know this CC and CU. So we know that CC.
Assalamualaikum sir and assalamualaikum everyone. Effective stress in a soil. What is this? This is the classical principle of the effective stress in soil mechanism. Soil mechanism is describe the pressure distribution of the soil selectron and the pore fluid for saturated soil. Introduction. Who is Tarjeti? Tarjeti is the one of the leading civil engineer of 20th century. Is widely known as the father of soil mechanics. Tarjeti developed the effective stress concept, which became a key concept in modern soil engineering. Effective stress in soil contribute to its strength, volume change, capillary rise, deepest force due to water flow, with quicksand having at the bottom of total stress various versus effective stress. Soil is an assemblage of particles of different shapes and size. So the soil selectron is a major body to resist against external force. In this picture, here is that I said. Okay, here is that, and as a result of applied external force. External force here, the soil is the force resist against external force. In dry situation, interparticle force are in equilibrium with internal force. Thank you, everyone.
Assalamualaikum sir. Assalamualaikum. I'm Mr. IC0.06. Today I will discuss about total stress versus effective charge. Let's start. Here is the slide. Here we see the slide. Here we see the picture. Here is here we see the slide. Here we are giving stress by a system. It's giving stress by a system. It is the total stress. It is defined as the sigma. Here we will K. Stress at the speed. Stress at the speed. Here is the soil at the water. And we will take four water pressure. So we have to write sigma equals to sigma prime plus.
Assalamualaikum everyone. I'm Mr. Kaja, ID is 6746. So I will discuss about effective stress competition in soil mass. In this part, we realized that its structure is determined by pressure on the soil, and this part we realized that there is a lot of pressure in our subsoil, which causes the soil to shrink. In this part, we see that diagram in soil layer, which is H1, H2, and H3, and its unit weight is gamma 1, gamma 2, gamma 3, and so on.
its respectively this portion is H1 gamma 1 and this portion is H2 gamma 2 and this portion is H3 gamma 3. So we calculate the effective total stress by using this formula. Sigma is equal to H1 gamma 1 plus H2 gamma 2 and plus H3 gamma 2.
Assalamualaikum everyone, I am Fazal and my ID is CN753. Now I am going to discuss about the effective stress equation of a soil with steady water table. Here in this figure we can see here is a soil, different types of soil, and here is the water table, and we have to derive the equation of effective stress from here. If we want to describe the effective stress, first we have to calculate the total stress, and the total stress for this area is H1 gamma 1. For this area the stress is H2 gamma 2. For this area the stress is H3 gamma 3, and for this area the stress is H4 gamma 4. And if we add this 4, we will get the total stress. Then there is water from this layer, and we can see the height of this layer is H3 and the height of this layer is H4, and in this two layer there is water, and the unit weight of water is gamma W. So for pore water pressure we get here H3 plus H4 into gamma W, and the effective stress equal to effective stress sigma prime is equals to total stress minus pore water pressure. If we subtract the pore water pressure from the total stress, we get the effective stress. Then rearranging, we can get another simple equation here. Here the effective stress is equals to the summation of the product of height and unit weight, the value of under water table, and here is the summation of here is the values for the layer under the water table, and here we can see a term. This term is called submerged unit weight. That means this is gamma prime submerged unit weight is equals to total unit weight minus the unit weight of water. So using this equation we can calculate effective stress easily, and we can also use the previous equation as we prefer. Thank you. That's all.
Assalamualaikum everyone. I am Rabia Khatami, IDCN 010676. Here we can see the two layers. One is for water and the other one is for soil. Also we can see the three triangles. The first one is for total stress, and the second one is for pore water pressure, and the third one is for effective stress. We can use those equations for calculating the total stress and the pore water pressure and the effective stress. As we can see, the water is acting uniformly throughout the soil layer. So that means it doesn't increase the interparticle stress. So this is the conclusion that the soil is not affected by the height of water table. Next slide. Here we can see that 4 types of soil. For total stress, pore water pressure, and the effective stress, we have to find the height. We have to subtract from this to this. For soil type 1, height. The height will be 4. The height will be 4, and for soil 2 the height will be 9, and for soil 3 the height will be again 4, and for soil 4 the height will be 9. For total stress. start from this layer, and the height will be the subtracting from this to this. The height will be 6. So the pore water pressure is the multiply the height and gamma W and effective stress. If we subtract the pore water pressure from total stress, we will find the effective stress. Thank you so much.